In this video, I would like to talk about titration curves. We know the titrations that we have done in Chem 1 and 112. So, in terms of titration, you are just adding acid and base to make something neutral. So in this case, you are adding acid and base to make something neutral, or to make a neutral solution. That's what you are doing in titration. So if you do the titration slowly, you are going to have a titration curve, and we'll talk about what the titration curves will look like. In this case, we are going to talk about several additions. That is what the curve will look like if you add a strong acid and a strong base, and also what the titration curve will look like if you add a weak acid. So we have weak acid and a strong base. Also, when you add a weak base and a strong acid. So lastly, we are going to talk about titration of polyprotic acids. That is, acids with more than one proton. So let us start looking at a curve, a titration curve for strong acid and strong base. So in this type of curve, what we are doing is, so we have a strong base and strong acid. But in this type of curve, we are adding. So we are starting with a strong acid, and then to that strong acid we are adding a strong base. So that's what this curve is showing in here. So the question is, how do we know that? How do we know that we are starting with a strong acid and adding a strong base? We know for two reasons. The first reason is that if you start with the acid, you are going to start with a low pH. So you can see that this part is pH, this part is the volume. So if you are starting with the acid, you are going to start with low pH. So you can see here we are starting with low pH. Starting with low pH means you have an acid in your solution. So that's the first part. So when you start with low pH, when you add base, the curve is going to be ascending. So as you are adding base, you see the curve doing this, going all the way there, and then doing that. It's ascending because adding base increases the pH. So we say that one, we know because the curve is ascending. So that's the first reason. The second reason that we know that it's a strong acid and a strong base is that the pH at equivalence point is equal to pH 7. So at equivalence point, that's when the neutralization has happened. So equivalence point is when neutralization has happened. So in terms of strong acid and strong base, the equivalent point has pH is equal to 7, as you can see here. So these are two reasons that will tell us that the curve that we have here, we are starting with strong acid and we are adding a strong base because the curve is ascending. And also this tells us that we have strong acid and strong base because the pH at equivalence point is 7. So that's the first one. Let's look at the second one. So this curve, we are starting, so we are starting with base and adding, so we say we are starting with a strong base, then we are adding a strong acid to that base. So the question is, how do we know this? So there are two reasons. The first reason is we know this because if you start with a base, your curve starts at higher pH. So you can see it is starting at 12 or it is starting at pH 13, which means before adding the other liquid, we had a base in that solution. So the pH starts at higher pH and then the curve is descending. So we can see that the curve is moving this way from up there and then it is descending. So if you see a descending curve, know that you are adding an acid to a base. So you started with a base which was at higher pH. When you add the acid, the pH decreases. Now, this second part is telling us that we are adding strong acid and strong base. So if you are adding strong acid and strong base, either way, you expect the pH at equivalence point must be equal to 7. So at this point, where neutralization is, pH is equal to 7. So those are the two reasons that will show you that we are adding a strong acid to base or a strong base to acid. The reason that will show us that we started with a base and added acid to the base is that the curve is descending. Now, what will show us that it's strong acid and strong base is that the pH at equivalence will be equal to 7. So let's look at another curve. So in this curve, we have a weak acid and a strong base. So So we are adding these two. So how do I classify this graph? So in this graph, I am starting with a weak acid. I am starting with the weak acid, and then I add strong base to that weak acid. So how do I know that? So how do we know this? Now we know this because of two reasons. The first one is that the graph is ascending. The graph is ascending. So if you see an ascending graph, it means you started with a base. Now let me make a correction. If you see an ascending graph, it means you started with an acid. So this shows that you started with acid, because acid is at low pH. So when you start adding the base, the pH will be increasing, and you will see that your graph will be ascending. So what else? Now the one thing that shows you that you are adding a weak acid and a strong base is that the pH at equivalent points, pH at equivalence point will be equal or will be greater than 7. So the pH at equivalence point will be greater than 7. That will tell you that you have a strong acid in, or you have a strong base in there, because base has pH greater than 7. So the equivalence point will be reached at pH greater than 7. If you look at this equivalence point here, the pH is about 8.1, which is greater than 7. So two things that you need to look for. The first one is the graph is ascending. The second one is that the equivalence point pH is greater than 7. So that will tell you that you started with an acid, or you started with an acid, a weak acid, and added a strong acid. And you can see here that it is showing that you are adding sodium hydroxide, and the pH is rising. Let's look at another graph. The same thing, weak base and strong acid. So this one, we are starting with base, and we are adding, that is, we are starting with a weak base, and we are adding a strong acid. How do we know this? So we know this for two reasons. The first reason is that the graph is descending. So this tells you that you started with base, because base is always at higher pH. So if you add acid to base, you will see that the graph will be descending. The second reason The second reason to tell you that you are adding a strong acid to a base is that the pH at the equivalence point will be less than 7. So as you can see, this pH here, the pH of 5.28 is less than 7. So this tells you that really you are adding a strong acid to a weak base, or it tells you that you started with a weak base and then added a strong acid to that. So you need to be able to recognize what you are adding here. You can see that we are adding HCl, which is an acid, to the base that we started with. Our weak base here is ammonia. So that's how you know these titration curves. So you need to be able to identify each of the titration curves that we have discussed. Then there is the last curve that we want to talk about. So this is a curve, titration curve for a polyprotic acid. So we start with defining what a polyprotic acid is. So this is an acid that has more than one proton. So an example is H3PO4. So you can see it has 3 protons. H2SO4. This one has 2 protons on it. H2CO3. This one has 2 protons on it. All right. So you can have another example here. H2SO3. So these ones are polyprotic acid. Like this one is triprotic because it has 3 hydrogens or 3 protons. This one is diprotic because it has 2 protons. So how do you know that your graph is polyprotic? So how do we know this? So we are going to know that our graph is polyprotic, actually diprotic or triprotic, by the number. Use the number of equivalence points. For example, this one has equivalent point 1, equivalent point 2, which means it is diprotic. So each equivalent point will be a neutralization. For example, if we have H2CO3, so we have H2CO3 and water to form HCO3 negative and hydronium ion. So this is the first neutralization that you see here. And then this one will also react with water to form this one and a hydronium ion. That's where you see the second equivalence point. So having two equivalent points means you have a diprotic acid. So this graph that we see here, it can be explained by this one. It can be explained by this one, because both of them are diprotic, and also even this one. While this is triprotic. It's triprotic. So if you have a triprotic acid, you expect to have the first equivalence point, the second equivalence point, and the third equivalent point. So you have equivalence 1, equivalence 2, equivalence 3. Each of these numbers represents the hydrogens, that are the protons that are going to be lost at each step of this reaction. So this, if you have a triprotic, it is a 3-step reaction. Step 1, you lose the first proton. Step 2, you lose the second proton. And step 3, you lose the third proton. So try to study these types of graphs, and you expect to see these on your exam too. So make sure that you understand this video. Thank you.